Hi guys, welcome back. Today we're going to be doing word problems with trig lengths. So example 1, two buildings 100 meters and 80 meters high are 60 meters apart. The sun casts a shadow from the 100-meter building onto the 80-meter building. If the angle of elevation of the sun is 22 degrees, calculate the height of the shadow on the 80-meter building. So a lot of times we have students come up and they say, read the question, they say they don't know how to do it. And my response is usually, you can at least draw the building. So let's start off and let's do the building. So what's going to happen is I'm going to do some really rough sketches here, and then I'm going to show you the really nice pictures that's behind the white area. So first off, two buildings. We have to include a sun. We've got our rays of sun that are coming down. It's going to nick the top corner of the large building and cast a shadow on the smaller building, because that's how they've said it's been done. This one was 100 meters. This one was 80 meters. And then they did tell us that the angle of elevation of the sun is 22 degrees, so that gives us this angle right here. So I'm just going to use an arrow. And they did tell me that the two buildings are 60 meters apart. So we get, my pen seems to be giving me issues today, 60 meters apart. So that's the basic sketch. Let's look at the really nice one. So this one looks much nicer. Same details, just straight lines this time. You might want to use a ruler. And then we have some information here that really doesn't matter to us, so I'm going to highlight it with the laser pointer. If we look here, that edge of this building right here really doesn't matter. And this section of the building here really doesn't matter because they're not part of the question. We are now looking for the height of the shadow, which is right here, on the smaller building. So let's take out some of the details that we're not worried about. And we end up getting this picture to the right. So we just kind of took out some of the details of the building that weren't important to us. Some things to note, the shadow is casting on the smaller building, so it's not going to encompass the entire building. That's why there's this little piece at the top here. It's not, the shadow isn't on the entire building, so that's why this part sticks out a little bit higher. But all the other details are here. We have the height here of the shadow, which is really what they want us to look for. So it isn't too hard. The one thing I would maybe label on these diagrams, our buildings usually stand straight up, so 90 degrees right there, and we should be good to go. So what we're going to start off doing is we need to figure out how to get the height, which is from here down to here. The 80 meters right here is from the top right at D all the way down. We want just right there down. So we have two triangles here. We have a large one and we have a smaller one inside it. They both share the angle of 22 degrees. And a lot of the times if you have one angle inside of another, or sorry, one triangle inside of the other, you need to use the large triangle to find out some piece of information in the smaller triangle. So it would be great if we could figure out what this length was, because then we could do opposite over adjacent when we use 22 as our reference angle. So what's going to happen is I'm going to use this side in the big triangle and this angle, and I'm going to find this entire side length, which I labeled x. And once I find that, I can do x minus 60, and that will give me this piece right here. So let's do that. So we start off by circling our reference angle, which is right here. We're probably at a point now where we don't have to go and label our sides. We can probably just see that we are dealing with opposite, because we're straight across, opposite, and beside, so we're dealing with opposite and adjacent. So that's going to be our tan ratio in the SOHCAHTOA. So we do tan of our angle equals opposite over adjacent, so that's why we have 100 over x. Whatever's in the denominator comes to the other side. Since it's divide on this side, it's going to come over and multiply with the tan of 22. And then the tan of 22 is going to come over and divide. Punch that on your calculator. So we just figured out what x was, which is this value right here. Some people like to go and actually write that in, and that's fine too. 247.51. So then now we can go and calculate what BE is. So that's just going to be this length right here is going to be this minus the 60 meters. So we're looking at, we want to calculate what BE is right here. So that'll be the 247.51 minus the 60. So we just showed it here. Again, super easy to reference BE. And then step 3 is going to be finding out what H is. And then we just finish it off. So if we look, it's nice to say what triangle you're working with, BDE, so BDE, but we're actually finding out what H is, which is just this portion right here. And again, this is still our reference angle, so we're going to have this side, which is opposite, over BE, which is adjacent. So we just write that out. Tan of 22 is opposite, which was H, over adjacent, which was the 187.51. Bring this to the other side and multiply, and we finish off. So you just have to, so H is going to equal 75.8 meters. You don't have to put the meters in this area right here. You would if it was just a basic question and not a word problem, but we're going to have a final therefore statement where we're going to include our units. So we end up with our therefore statement. Therefore, the shadow on the 80-meter building is 75.8, and you include your meters there at the end so that you don't lose any marks. Let's move on to the next one. This one's fairly easy, so I'm not even going to cover up the portions of the solution. It says the Calgary Tower is 190 meters high and casts a shadow 84 meters long. Find the angle that the sun's rays make with the ground. So you just draw a tower, and sometimes it's easier just to do the straight line so that you don't have to draw two pictures. So I have a tower that is 190 meters tall, and then most buildings stand straight up except for one. And that's going to be 90 degrees there. And then they say that the shadow is 84 meters long. So that is the shadow that would be running across the ground. I get some students that put the shadow up here, but that's not the length of the shadow. The shadow has to run along the ground. And then they said, find the angle that the sun's rays make with the ground. Well, if this is the ground, this is going to be the ray of light that created the tip of the shadow right there. So we must be finding this angle. A lot of times in math, they use Greek letters to represent unknown angles. So this one, it's just a dash with a circle around it. It's called theta. You'll see alpha. You'll see beta. You'll see upside down fish. I can't remember what that one's called. So you'll see them. We could use capital A, we could use capital B, but you'll find a lot of times that we also use these Greek letters. They're just another representation for an unknown, and you're going to have to get used to them because they're not going away. You'll see them quite often. So again, this is my reference angle, so I circle that. This is a step I seldom skip, even for me. And then from here, I can see this would be the opposite, and this would be the adjacent. This would be the hypotenuse, but they didn't ask me for it, and they didn't give it to me, so I'm not worried about that. So again, I have opposite and adjacent. That's going to be my tan ratio. So tan of my angle, which was theta, that's what I'm looking for. Opposite over adjacent, the 190 over 84. Take the tan to the other side, you'll do tan inverse. Please don't say tan to the -1, we say tan inverse. And you can do this on your calculator. You just open a bracket, and then 190 divided by 84, and close the bracket. And that's great because then your calculator does all the work and it uses all the decimals. I have some students that figure this out as a decimal first and then do the tan inverse of it. And if you're going to do that, it's fine, but make sure you take all the decimals. Another way you could do it is on your calculator go 190 divided by 84, hit equals. Then you can go shift tan, and if you have a last answer button, you could do that as well. And again here, I would go to the nearest degree because they didn't say how to round. So let's take out that decimal 1. I know it's like magic. They didn't say round to the nearest decimal, 1 decimal place, so you assume that it's to the nearest degree. And that's always going to be for this unit. If they don't tell you, angles go to the nearest degree, side lengths go to the nearest 1 decimal place. Please don't ask in the middle of a test. Let's see what's on the next slide. Again, we're going to do this the same way. I'm going to do a rough sketch, then I'll delete it and show you the very pretty one. Example 3. Jane is flying a kite. The angle the kite string makes with the horizontal is 37 degrees, and she has let out 23.5 meters of string. If she is 1.4 meters tall, what is the height of the kite? So again, I have students come up to me and they say, I don't know how to do it. And I said, well, let's start by drawing a kite. So don't be that student that just comes up because they don't know how it's going to end. At least you can draw me someone drawing a kite or flying a kite. So let's draw it. Jane is a tall woman, apparently. So if we look here, that's Jane flying a kite. They say the angle the kite string makes with the horizontal. So the kite string makes with the horizontal is 37 degrees. And she has let out 23.5 meters. So 23.5 meters. That's going to be the string, which is right here. And then they said if she is 1.4 meters tall. So that's assuming that she's holding the kite similar to where her height would be. So that means that this height right here to the ground would be about 1.4 meters. So let's label that. We're going to get 1.4 meters. That's from here to here. And that's the ground that she's standing on. So let's take a look at the really nice picture now. This time Jane is not as tall as she was before. So if we look, we have this piece right here, which is X. That is the portion that is in relation to the triangle with the horizontal. But they want us to find the overall height, which goes all the way down to the ground, which isn't in here. You might want to add it. And that's going to include the extra 1.4 meters sitting right here. So let's go and first find X, and then all we have to do is add 1.4 meters to it. Circle your reference angle of 37 degrees. Label your side lengths as opposite, adjacent, or hypotenuse. So this one's going to be opposite, and this one's going to be hypotenuse. So we haven't done this yet, this note, but again, SOHCAHTOA. This is where the opposite and hypotenuse are, so we're using the sine ratio, and we end up getting sine of our angle, which was 37 degrees right here, is equal to opposite over hypotenuse. The 23.5 comes over and multiplies. Punch that on your calculator, you get 14.14. I would take the extra decimal place here, and the only reason I do that is because it is not our final answer yet. So you want a little more accuracy until you get to the very end, and when you write your therefore statement, you can round it to 1 decimal place because it's a side length. I find out that X is 14.14, so my height is equal to X plus the 1.4, and I end up getting 15.44 overall. And then we write our therefore statement. And you can see, therefore, the kite is 15.4 meters high, and I rounded it to 1 decimal place. So right here, 1 decimal place because it's a side length. You could have rounded it here as well because that was my final solution. You would take 1 extra decimal place here just so that you have the correct accuracy at the end. If you have many steps involved and each one of those is getting round to 1 decimal place, you might be off by a decimal place at the end. That's why you take an extra one. If you look a little lower, we end up having our homework. Again, we do that tomorrow. If you're wanting to take a peek at it tonight and then you're that much further ahead for tomorrow, that's fine. And I hope you guys have a good night. See you tomorrow.